Welcome back. Unit 5 deals with geologic time, sedimentary rocks, and processes of weathering and erosion. Much of Earth's history is represented in sedimentary rocks, rocks that are formed from pre-existing particles of older rocks and minerals. These particles, or sediments, are accumulated at the surface of the Earth. The environments of deposition, such as beaches, rivers, lakes, deserts, and even the ocean floor, are continuously recording the comings and goings of activity at the surface of the Earth, even as we speak. This is also where we find fossils. Some sedimentary rocks, such as quartz sandstone, represent ancient environments such as beaches, deserts, and even river channels. These are formed of tiny grains of quartz that have previously eroded and weathered away from quartz-bearing igneous rocks such as granite. Even sedimentary rocks like this sandstone can re-weather, producing the strikingly erosional features seen in places like Arches National Park in Utah. Other sedimentary rocks, such as this limestone, form in marine environments and are controlled by ocean chemistry, in this case the concentration of calcium carbonate in seawater. Note the marine fossils in this limestone, preserving a rich and complex ecosystem from hundreds of millions of years ago. We live out our lives in terms of decades, maybe a century. Even 1 million years seems too big to imagine, and 4.6 billion years of Earth history just seems unfathomable. Here's the geologic timescale, a table that shows the history of Earth. Notice how most of the planet's history is represented by the Precambrian eon, approximately 4.6 billion to about 570 million years ago. During this time, our planet took form, continents were built, and our atmosphere evolved. But still, how can we comprehend the amount of time that we're dealing with here? Well, recently, a video was produced to assist in illustrating the history of the Earth. Imagine if the entire history of our planet were to be placed along a straight line from Los Angeles to New York City, and we use that distance as a gauge for this timeline for the last 4.6 billion years. Let's look at how major geologic events in our history are spaced out along this timeline. That's really quite striking. So for this unit, our learning objectives are: become more familiar with different sedimentary rocks and what they tell us about ancient environments. Second, understand processes of weathering and erosion in context with sediments and the rock cycle. And finally, understand concepts of geologic time and how these concepts are determined. Just like before, know the unit deadlines, know when your things are due. Remember, you have 2 attempts on the assignments, 1 on the exam, and pace yourself. Good luck and enjoy.